Hello, everybody. So what we're going to look at today is section 3.4 in your textbook, which is composition of functions. Now, I'm going to kind of assume that you've seen the lecture for the first part of this and get to actual composition of functions as quickly as we can, because that's where the material is the hardest anyway. So we're going to kind of rush through the beginning of this a little bit, and I think that will be for the best. So anyway, what this section is about is not just compositions of functions, which have a specific meaning, but it's also more like combinations of functions. It's just called in the textbook compositions, even though it doesn't just cover compositions. So basically, if you have a function, right off to the side here, if you have a function f of x, you can take that function and you can do a lot of things to it. So you can multiply it by a constant. So you can do a c f of x, where c is a number. Or if you have two functions, you can take the first function, call it f, and add it to a function g. Of course, if you can add two functions, you could subtract two functions. That's also allowed. And you can multiply functions. You can take an f of x times a g of x. You can divide functions, f of x over g of x. When you divide functions like this, f of x over g of x, you do want to be careful that the denominator, g of x, is not allowed to be 0. If it was, then you would have a divide by 0. So normally you would write this off to the side, okay? And then finally we get to real function composition, which is where you put a function in a function. And so the notation is something important to notice here. So if you wanted to write f of g of x like this, you could of course write it like this, but the other way to write it is f of g of x like this. And so they use this open circle. They use that open circle symbol to indicate function composition. And you just have to know that the g is being plugged into the f here, right? So it's f of g. Also, the open circle here is not multiplication. You can use a dot like this small dot for multiplication if you want to, but the solid dot is not the same thing as this open circle, okay? Now, I realize that I just said what all those were very quickly and we didn't do any of them, but that's what we're going to do on the next page is just make sure we understand these. Okay, so with this example, we should be able to see if we understand what's going on here. Actually, if you were in lecture, you probably saw this first one being done. So I'll skip to the second one and we'll do this one instead. Same type of problem. So what are we doing in this set of notes or in this example problem? We've got two functions. Okay, we have f of x, which is 5 over x squared, and we have g of x, which is 3x. So those are just two separate functions. And then we have several things that we want to find here. 5f, f plus g, g minus f times g, f over g, g over f, and g of f, and f of g, right? So these are kind of just going through all of those different types of operations that we had here. So let's try to work these out. So when we say 5f, what we mean is 5 times the function f, and the function f is here, 5 over x squared. So we just write 5 and then 5 over x squared. Now notice that I put parentheses around the function. That's important because if there had been multiple terms here, then they all would have needed to go in the parentheses. We had that, I think, on this previous one here. So this one we skipped, but like if we wanted to do negative 4f on this example, it would look like negative 4 parentheses f, and f is 3x plus 5, and you would put the 3x plus 5 in parentheses like that. Okay, now I don't want to continue on this example, but maybe we'll come back to it. We'll stick with this function though for now. So 5 and then 5 over x squared. And then this you would just multiply out, which you don't need to do. You don't need to be super careful about it, but I will here. 5 is 5 over 1. And then 5 over x squared is 5 over x squared. And when you multiply across the top and you multiply across the bottom. So we have 5 times 5 on top would be 25. And then on the bottom, we have 1 times x squared, which would be x squared. So 5f is 25 over x squared, right? So that's just multiplying by a scalar. Then we have f plus g. So f plus g, well, it's just equal to, I don't know why it keeps zooming in like that. F plus g, well, f plus g, well, this is f and this is g. So there's nothing to it. You just write f plus g. There they are, f plus g. Done. G minus f. Well, whenever you have a negative sign like this, to be careful, you should use parentheses. And maybe we'll go look at the other example real quick here after this. So we have g minus f. So just we'll put g here, we'll put f here. So g minus f. G is 3x. And f is 5 over x squared. Like that. Then we realize that we don't need the parentheses anymore. So this is 3x minus 5 over x squared, and that's all you have to write. Now, regarding the parentheses will be important when you've got, again, multiple terms inside the parentheses due to, the f or the g being multiple terms. So like if I come here, for example, this one we have f minus g for what are the f and the g here? Here the f was 3x plus 5 and the g is 2x minus 3. So when you subtract parentheses, your f, which is first here, is 3x plus 5, 3x plus 5, and then minus g. G is 2x minus 3, 2x minus 3. And to simplify that, it's important to understand that this negative is going to have to distribute. And that's why you need the parentheses so that you don't accidentally skip that step. So this one would be 3x plus 5. You don't need parentheses there. But then minus 2x, which would be minus 2x. And then minus 3. Minus 3 would actually be plus 3. Like that. And then you have to combine your like terms on this example. So what I would do is I would just realize that the 3x and the negative 2x are like terms. 3x minus 2x is just x. And then the 5 and the 3 are like terms. Positive 5 and positive 3, that will add up to 8. So then this would be what f minus g is. And so you do have to be careful and use parentheses when you've got multiple terms like that. Otherwise, you would get the wrong sign on this 3, and then the whole thing would be wrong over here. Okay, so I hope that makes sense. All right, continuing on. F times g. So when you have f times g, Well, it will be f, I think f is 5 over x squared, yeah. G is 3x, like that. We need to multiply these. To multiply them, we should write them both as fractions. So 5 over x squared times 3x, you can write 3x as 3x over 1, like that. Okay. And then you can multiply across the top and you can multiply across the bottom. So multiply across the top, 5 times 3x is 15x. Multiply across the bottom, x squared times x times 1 is x squared. So we end up here. However, on the homework, which we'll look at in a minute, you do need to be careful that you are going to cancel your x's. If there's an x on top and an x on bottom, we can cancel that. So we can cancel that x with 1x in the denominator, and it will leave us with 15 over x. Okay, so that would be the answer. We cancel one of those x's. All right. Next one, f over g. So f over g, f is 5 over x squared. G is 3x. So we have this. When you have fractions over fractions, you want to remember how to deal with that. And basically, it's like this. So if you have an a over a b over a c over a d, that is equal to a over b times d over c. And so notice that this is c over d, but when you change division to multiplication, you change instead of dividing by the fraction, you end up multiplying by the reciprocal of the fraction. So this is c over d, this is d over c. It's upside down, the reciprocal. Okay, and if you can remember this rule, you can handle stuff like this, because we got a fraction on top. On the bottom, it's not a fraction, but you could easily make it a fraction, right? You can write the 3x as 3x over 1, and then now this and this look like the a over b and the c over d. Then we can proceed and write this as 5 over x squared times 1 over 3x, like that. And once we write it this way, we know to multiply across the top and across the bottom. So 5 times 1 will be 5 on top. On the bottom, x squared times 3x is going to be 3x, and the power will be, well, this is x squared and this is x to the 1. You're going to add those exponents and get x cubed. Okay, so there we go. Also notice that what we should also say here is where, going back up to the top, remember that the denominator g is not allowed to be 0. So the denominator here, actually technically this one, 3x, cannot be 0. So 3x is not equal to 0, but of course that means if 3x is not 0, that means x can't be 0. And that's probably the one you would want. So that version. Okay, so there we go. Then we have g over f. So same thing, but now it's going to be upside down. We have 3x on top and 5 over x squared on the bottom. Now, you still want to do the exact same thing so you can apply this rule. So the 3x that's on top, we probably still want to write it as like 3x over 1. And then you can take this fraction and say it will be 3x over 1 times the reciprocal of 5 over x squared, which would be x squared over 5, and then multiply across the top and multiply across the bottom. So across the top, 3x times x squared is 3x to the 3. And on the bottom, 1 times 5 is 5. And of course, you notice that this is the same as what we had up here, just upside down, right? Because this was f over g and this is g over f. We just reversed the top and the bottom. So this and this are the same, just upside down compared to each other. Also, there is no way for this denominator to be 0, so we don't have to write anything like this, right? The 5 can't be 0. Okay, so division. Then we get into the composition of functions. Now, I'm actually going to leave these blank for now because I want to come back to them once we know a little bit more about composition of functions. Okay, so let's skip ahead a little bit to more on composition of functions. Okay, so yeah, okay. So on more on composition of functions. So we're going to take a little while before we actually calculate these kinds of things. I want to work with numbers first, and then we'll come back to this. Okay, so let's just think about composition of functions. So if we wanted to calculate a composition of functions, we might be calculating numbers like this one, like f of g of 4, right? When you put a function in a function, that's called composition of functions. Okay, and now how would you calculate numbers here? Well, if we wanted to calculate numbers here, it's going to be different based on whether we have a table of numbers to look at like this, or if we have graphs of functions like this. I think I took this one from either the homework or from your textbook. And yeah, so when you're doing numbers, it could be done either way, right? With tables or graphs, or with formulas, which whatever you have is what you use. Now, how would we calculate this? A function in a function, something like f of g of 4. So the way you always do this is as follows. So, I mean, you can read the text here if you want, but I'm going to just tell you. So to calculate f of g of 4, this is what we want. The first thing you're going to do is you're going to calculate g of 4. So step 1, compute the inside. So compute the inside. So we need g of 4. So here we need to find g of 4 using, in this case, the table. I have a table of values up above, and we're going to use it. Okay, so we go to the table of values to look up g of 4. So here's my table. So if we're looking up g of 4, what you do is you look across the x column for the 4. There it is. And then you look down to the g or the g row in order to find the value. So you go over to 4 and then down to g, right? Because this is x row, f row, g row. So over to 4, down to g, and we find a 6. So that says that g of 4 is 6. Okay, so we read that value from the table. So we find g of 4 using the table. G of 4 equals 6. Okay, so then we take this g of 4 and we replace it with 6. Does that make sense? So g of 4 is 6. At this point, you now have f of 6. So your second step is going to be, okay, well, this is f of 6. Now you go back to the table and we're going to find f of 6 using the table. So it's just a completely independent step here, f of 6. So you just go back up to the table, forget about what we did previously, and say, how would we find f of 6? Well, you start with the x, go over to the 6, and then we go down to f. There it is, right? So this right here, this is f of 6. F of 6 is minus 1. And there you go. So to summarize, you can just write this in one single line. You can say f of g of 4, but g of 4 is 6. And then f of 6 is -1. And that's your answer. Okay, so that's how compositions are worked out. Now notice that there's no rule that says that f has to be on the inside or the outside. In this case, f is on the outside. On this next examples here, I have f on the outside, g on the inside. I have g on the outside, f on the inside. And then this is just another example, f of g of 6. So g is on the inside here. Okay, and this is how you work them out. So like if I want to do this one, f of, what are we going to do? Well, we're going to look up g of 2 in the table. So you go up to your table, we want g of 2. So you go over to 2, down, whoa, and then down to g. So we end up at 4. G of 2 is 4. Fill that in. Now you have f of 4. So we need to look f of 4 up in the table. So you forget about what we did, f of 4. So we go over to 4, down to f. And we're at 3. 3. That's the answer. Let's do one more here. G of f of 5. This time, f of 5 is in the middle. So we're going to look up f of 5 first. You do the inside first, f of 5. So you go over to 5, down to f. And right there, f of 5 is 1. So we have g of 1. So g of 1, we need to look up g of 1 in the table. So you go back to the table, forget about what we just did, and we need to go over to 1 and then down to f. And we have, wait, is it f? Hold on. No, g of 1, sorry. So you have to go over to 1 and then down to g. So here, g of 1 is 3. Like that. So that one's also 3. Okay, I'm not going to do this last one. I'm just going to say that what it means is f of g of 6 means this. So once you write it like this, then you can do it the same way we did with the table. Okay, so that's composition of functions with, just looking up numbers. Let's try to do this with a table of values. Conceptually, there is no difference. Okay, so conceptually, there's no difference at all. You just are using the graph to get your numbers. So let's just try this. So this one says, example, use the graphs shown to compute f of g of 1. So this is f of g of 1, like that. We need to compute first g of 1. So compute g of 1. What is it? Well, we have to look at our graphs. So let's look at our graphs carefully. So we've got the second graph is f. So this is f. This is g. So this is the graph for g. We are looking up g of 1. Compute g of 1. So our x value here, that's an x value of 1. So to get g of 1 on the table, we would come over here to x equals 1. And then we would go up here on the graph to get the g value. And g of 1 looks like the y value here is 3. So it looks like 3. So g of 1 is 3. 3. Okay, now once we do that, now we have to look up f of 3. So we go to the other graph to do this. So now we have 3 here. That's going to be x equals 3 when we look it up. So now we have to compute f of 3 using the table. So we have what? Well, f of 3. So the second graph, this graph is f. So what we would do is we would come over here to 3, x equals 3, and then we would come up here on the graph to get the y value right there. And from this, we can see that f of 3 looks like it is 6. And that would be my answer. Okay, so that's how you compute function values for compositions using a graph. Okay, let's just do one more. Won't hurt. This one is g of f of 2. So first thing to do is to look up f of 2. So we're going to do f of 2. How would we do it? Well, we go to the f graph, which is this one. You go over to 2, and then you go up here, and right there. That would be f of 2. So it looks like f of 2 is 5, the y value there. Okay. Then we have g of 5. So we're going to go to the g graph, which is the first graph, and it's g of 5. So you come over here to the 5, and then you come up here to get the dot, and it looks like g of 5 is going to be 3. And there you go. Answer is 3. Okay, so those are actually pretty straightforward, and the graphs are maybe a little bit harder than the table of values, but basically it's the same process, okay? Now let's actually go into what is a little bit more trouble, which is going to be finding equations for compositions, okay? And my advice here is to do this in a very systematic way, okay? What I mean by that is, well, as follows. Also, it looks like I kind of forgot some parentheses on these. Here's what I would do, okay? So if you're looking for this, f of g of x, and we're trying to get a formula for that now. So here's how I do it. First of all, the of x thing is a little bit distracting to write the x, a little bit distracting. So just to make it easier on myself, I'll just say, well, we're doing f of g, okay? That's what we're doing, all right? And actually, even though I just wrote this down, I just realized I don't want to. I don't want to write this down. Just notice that f of g of x and f of g, I'm really talking about the same thing, okay? But let me erase this. It's in the way, and I'll show you what I really recommend here to do this. So the outside function here is f of g, or is f, right? The outside function is f. So what I would do is I would write this down. I would say, okay, so we know what f of x is, right? It is, according to this, x squared plus 5x. Okay, well, if f of x is x squared plus 5x, then that would mean, that says then, believe it or not, f of g would be what? Well, I just replaced the x with the g, right? So let's replace these x's with g's. F of g would be g squared plus 5g, right? So all I did was I started with f of x, I replaced all the x's with g's, and I got this. Okay, now then what you want to do is say, okay, well, this is g squared plus 5g, but what is g? Well, there's a formula for g. G is 7x plus 7. So what you do is after you do this, you are going to just replace all the g's with what the formula for g, which is 7x plus 7. Okay, so what would it look like? Well, I'm just going to write this out again, f of g, and it's what? It is g squared, but g is 7x plus 7. So 7x plus 7 squared. That's what g squared is. And then I have plus 5g. Well, g is 7x plus 7. So 5, 7x plus 7. Like that. Okay, and then that is technically the answer. This is the formula for f of g, or f of g of x. The only thing here is that it's not simplified, it's not multiplied out. But you can always do as much work here as you want to simplify this. So like this 7x plus 7 can be FOILed. You would get 49x squared plus, what would you get? 49 plus 49 would be 98. So plus 98x plus 49 plus, and then if I FOIL these two out, or not FOIL, but distribute, 5 times 7x is 35x. And then 5 times 7 is 30. Oh, that's not writing. Plus 35. And then you can combine your like terms, which, let's see here. I do have a calculator, so I can do this pretty quick. So 49x squared, and then you've got 98x and 35x. So 98 plus 35 is 133. Dang it. Keep getting Twitch notifications that are in the way of the things I need to click on. 133x. And then you've got 49 and 35. For constant, 49 plus 35 is 84. So that's what f of g is. Okay. Now I realize that that's a little bit quick, but we're going to do a few more examples of this. Okay. So like this one is g of f of x. So how would I do this? So I would start by writing g of x. So I would go g of x is 7x plus 7. Then I would say, okay, but I'm not looking for g of x, I'm looking for g of f. So replace the x's with f. So g of f is 7f plus 7. Okay, then what I would do is I would say, okay, but I need to replace this f now with the formula for f. And if I do that, I will have 7f, but f is x squared plus 5x. X squared plus 5x. And then you still have, the plus 7 on the end. So this is what you get. Then if you want to simplify it, you can. So I would say g of f of x is, and then what is it? Well, we can multiply this out. 7 times x squared is 7x squared. 7 times 5x is 35x. And then plus 7 is plus 7. And there would be your answer. So notice that these go pretty quickly. Sometimes if you follow my method for doing this, but some are definitely trickier than others. So let's try this one. This one has some fractions in here that will be a little bit confusing, but we'll still follow the same method. So on this one, f of g of x. So again, if the outside function is f, I'm going to write f of x first. Then I'm going to replace the x with the g. Write f of g, 1 over g plus 3. And then I'm going to fill in what g is, which is all of this, 1 over x plus 4. So I'm going to get f of g is 1 over g, which is 1 over x plus 4. And then I still have that plus 3, right? Because the 1 over x plus 4, that's the g. So this is done, but again, you can simplify it. And I say to use a computer to simplify that, and I'm going to in a minute here, okay? But I can do a little bit by hand here. So f of g, at some point I start writing the x back in because it looks nicer. How would I simplify this by hand? I would just do 4 plus 3 is 7. And I would say that this is 1 over x plus 7. And that's not a great way to write the answer, but also simplifying it is a little bit more trouble than we should have to deal with in a class like this. So I'm going to just open up a web browser here. I'm going to try to remember this function, 1 over x plus 7. Let's go to Wolfram Alpha to simplify stuff. So this is my preferred website for simplifying equations. And I'm just going to type it in. 1 over parentheses 1 over x plus 7. Type it in, hit enter. I will be able to verify that I typed it in correctly, like 1 over x plus 7. That looks right. And then I'm going to scroll down and hopefully they simplified it for me. There we go. X over 7x plus 1. Alternate form. X over 7x plus 1. Now, how would they get that, by the way? Well, I'll just show you by hand that what they did was they said, well, we don't like having a fraction in our fraction. So what we're going to do is we're going to multiply by x on the top and by x on the bottom. And if you do that, you get, well, on top, you get 1 times x. And on the bottom, you get 1 over x times x plus 7 times x. And then you can do a little bit of canceling here, very little, but that x can cancel with that x. And what you've got then is on top, 1 times x is x. On the bottom, you've got 1, and then you've got plus 7 times x, which is 7x. So that's how they simplified it. But I did it on the computer because I want you to know that you can work these out on a computer. Now, also, while we're doing this, I do want to show you that you can work these out completely on a computer. So what you could do is as follows, if you get stuck on some of these on the homework. So what you want to do is ask for what you want. So we need to find f of g of x. So I say f of g of x, parentheses, where, and then you type in what f and g are. So what's f? There it is. F is 1 over x plus 3. So you say where f of x is 1 over parentheses x plus 3. And g of x, what's g of x? Well, we have to look it up. Scroll over to it. Where is it? Oh, there it is. G of x equals parentheses. I don't need parentheses. 1 over x plus 4. So this is how you type it in. And if I hit enter, it'll work it out. Make sure it calculated what you want. Where it says input or interpretation, just make sure that the f is right, the g is right, and the f of g of x is right. And you get your result. Look at it. 1 over x plus 7. So it actually did not simplify it. It actually wrote it the way that we did at first, which was there, um, which is fine, you know. And then there's an alternate form, which is our simplified form. Okay. Now, there is one thing I want to mention though. So in the book, in the homework, they sometimes ask for f of f. And that's a problem because if I type in f of f like this, f of x, so there's no g. If I type in f of x, a lot of times Wolfram Alpha will not understand me. Um, See how it wrote 1 over f of x plus 3? That's not really what I want the answer to look like. Has a derivative here. That's not what I want. That's a calculus thing. So you see it really didn't work the way that I wanted. Um, and so there's kind of a trick to make it do what you want if you're trying to calculate f of f or g of g. And the trick is um, don't write f of f. What you want to do is write an f and a g, right? An f and a g, just make them the same, right? So here I typed in f equals 1 over x plus 3 and g equals 1 over x plus 3. And then if I ask for f of g, right, f and g are really the same. So I'm getting f of f. But when you do it on Wolfram Alpha will not be confused. It will actually do what you want. So that's my advice if you're trying to calculate f of f or g of g on a computer is type in the same function for f and g and then do f of g. Um, okay, let's go back to the notes here. Oh, that's actually the end of the notes. I guess let's do one of these, I guess. What are we doing? I said we would do g of f, f of g. Let's try that here. Um, Actually, no, let's not. Let's go to the book homework here. MCCD. All right, let's load the class. Let's go find some homework. Let's look at the previous homework. Teacher preview. And let's go. Stop, please stop. Let me scroll. So one thing that people had trouble with on this homework assignment was understanding what was going on here. So notice that these all say find and simplify. So they did expect you to simplify these. So like for example, on can't really point to it, but the one that says here, find and simplify h over g. Hint, you will need to factor h. That's a little bit tricky. If I go to my notes so I can write, just scroll to get some blank paper. Um, Let me write them down. So I have h is 12x squared plus 54x plus 24. And then I've got g, which is 2x plus 8. And then down here it says find and simplify h over g. Hint, you will need to factor h. And so h over g is going to be easy to write, right? H over g is going to be, well, just 12x squared plus 54x plus 24. And then on the bottom, just 2x plus 8. And they say, simplify, you're going to need to factor. Well, how is that going to look? Well, what that would look like is this, okay? So on the bottom, 2x plus 8, you can take out a 2, and you would have x plus 4. On the top, well, you can factor out, look for numbers that go into all these. So like, let's see, like 54 is 9 times 6. Actually, 6, it looks like, goes into all of these, right? 6 goes into 12, 6 goes into 54, 6 goes into 24. So you can take out a 6. Now, we're not going to get very far with this, but let's take out a 6, and you will be left with 2x squared, right? 6 times 2 is 12. It's a 2. Plus 54, well, we took out a 6, so we'll have a 9x. And then 24, 6 times 4 is 24. So I can factor out a 6 like this, but this right here still needs to be factored. I would really recommend that you just use a computer. Factoring stuff like that is probably going to be a waste of time in terms of how much time it takes versus what you get out of it. So let me go back to Wolfram Alpha. And I'm not going to simplify the whole thing here. I am just going to factor it. If I type in 2x squared plus 9x plus 4, it should factor this for me. If not, I'll say factor. It did, right? The alternate form, 2x plus 1, x plus 4. Or if it didn't do what I wanted, I can ask it to factor. And in fact, I'll go back all the way to here. I'll just say factor 12x squared plus 54x plus 24. And you'll see that it'll just factor the entire numerator for me into 6, 2x plus 1, x plus 4. So the reason I would want to do that on a computer was because it was fast, right? And now if I factor that numerator, I get 6, 2x plus 1, x plus 4. And on the bottom, I have 2, x plus 4. And the point is that you can notice if it's factored that you have an x plus 4 on top and an x plus 4 on the bottom. And that means you can cancel them, which would leave you with, also, let me do one more canceling, sorry. You have a 6 and a 2, so you can cancel the 2 with the 6, leave you with a 3, and you would end up with 3, 2x plus 1 over, oh, actually the entire denominator just canceled, right? It's just a 1 down there now. And then from there, well, maybe you actually just want to multiply this 3 back through and have 6x plus 3. So if you factor the top and the bottom, there might be things that cancel. So what I get, 6x plus 3? 6x plus 3. So if I come back here, if I type in here, 6x plus 3, then that should be right. Also here, something not to be confused about is like the bottom one here. It says the domain restriction for g of x over f of x is, and they're actually referring to the f up here, f of x equals -2. And the denominator would not be allowed to be 0, right? So if you have an f of x on the bottom, oops, sorry. If you had g of x over f of x, right? You're not allowed to divide by 0. F of x is not allowed to be 0. And on this problem, f of x was, for me, you might have different numbers, 2x, -2x. So, or -2x is not 0. Now, you can just divide both sides by -2 here, and you'll get that x cannot be 0. And so that's what they're going for on that last problem, where it says x cannot be 0. I'm not going to do the other ones up here, but you can do the rest of these by hand as well. Find and simplify, and you can get a computer to do them as well, just like I showed. for the composition. All right, let's go down here. Let's see if I find anything weird. Oh, hey, look, we did that exact example. Um, okay. Um, these are just kind of keeping track of symbols. We can look at them. Let's, sorry, I'm trying to use a computer or an iPad actually. So like this is number 5 here. So we have a function, it says called d of p, and those variables mean something. The d and the p mean something. Um, d is number of items demanded. When the price is p, then the cost is the cost of producing x items. So c of x is cost of producing x items. So they say to determine the cost of production when the price is 7. Well, what you would have to do is this. So you can take, so $7 is a price, right? So where does price go? You got two functions. You have a function d of p, and you have a function c of x. Well, if $7 is a price, then it has to be a p, right? $7 is a p. So the 7 goes into the d equation. So you've got d of 7. Somewhere you need to have d of 7. So automatically, looking at these examples here, it says d of c of 7. That's wrong, right? So this one is wrong because um, 7 is a price. It can't be plugged into C because C doesn't take a price. It takes X, which is items. So that's wrong. Solve D of C equals 7. Well, that one says D equals 7, but D is demand. It's not demand that's 7, it's price that's $7. So that's wrong. This one, well, that one has a D of 7. So that actually might be right. This one here, this says C of D of P. Well, C is cost. Cost is dollars, but cost is not price. And the 7 is a price, not a cost. So that one's wrong. So just automatically, just by knowing that $7 is a price, meant that 7 has to go into the D equation. It's D of 7. And so this is the only one it could be. So it's just keeping track of what all the variables mean. Okay. Um, here, come on, scroll. Let me scroll. Why won't you let me scroll? Okay. We did ones like this. We did ones. Let me scroll. Well, let me zoom. No. Okay. Now I can scroll? No, of course not. Scroll. Now I can scroll. Okay. A lot of these look okay. So there's two types of problems we haven't looked at. These 10 and 11 here. Um, so let's look at 11 because 11 looks like something that I kind of talked about. F of x is 5x plus 4, and we want f of f of f of x. Let's do that. F of f, 3 f's, right? So if f of x was, what was it, 5x plus 4? Is that right? Find f of f of f of x. And I'll show you how to do this on a computer as well. But so how would you do this? Well, the same as we've talked about before. F of x is 5x plus 4. So f of f is 5f plus 4, right? Replace the x with a 5. Sorry, replace the x with an f. And then here for the f, we have to replace that f with the formula for f. So you put in 5x plus 4 for that f, and you get 5x plus 4 plus 4. So this is f of f. Multiply that out. I will get 5 times 5x is 25x. 5 times 4 is 20, and then plus 4. So you have 25x plus 24. That's f of f. Okay, now this is not the answer. But stop here, come back, and start over with f. F of x is 5x plus 4. Basically what we did here, we're going to do again, but you'll see a difference. So f of x is 5x plus 4. So if I did f of f, I want to change the color here. I want it to be very obvious that they're different. Right? If you replaced x with f of f, that would be 5 f of f plus 4, right? Replace the x with f of f. And then from here, you would take the f of f and you would replace f of f with whatever the formula for f of f is. What's the formula for f of f? Well, it's right here, right? That's what we just calculated. So you would rewrite this 5 f of f plus 4, 5 parentheses for the f of f, and then plus 4. And you put the f of f, which I was writing in green, right there. So you would have the 25x plus 24 right there. And this is what you would get. And then you'd multiply it out. 5 times 25x is 125x. 5 times 24 is 120. And then plus 4. So you end up with 125x plus 124. And that is f of f of f. 3 f's. Okay. Now, how would you do that on a computer? Well, let me show you. Go to Wolfram Alpha. So you do it in stages. So you would say this, you'd say f of g of x, first of all, where f of x is 5x plus 4, and g of x is 5x plus 4. Remember how I said the easiest way to do f of f is to do f of g, but use the same f and the same g, the same function. Okay, so if you do this, it's going to calculate f of f. Okay, there it is, 25x plus 24. So then what you do is you say, okay, well, that's f of f, 25x plus 24. So now let's do f of g, where instead of g being the same function, let's make it 25x. Why can't I type here? Come on. Let me type. Plus 24. So now do f of g, where g is 25x plus 24, because that's really f of f. And then we'll do it and give me 25x plus 124. So you have to do it in 2 steps if you do it on a computer, but you can do it on a computer. All right. Well, that's not what I wanted. I wanted one more problem on here. Let's do this one. Express the function in a form f of g. X plus 2 to the 6th. I'll show you on notes. 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 There we go. So this will be our last example. Express like h of x equals, I don't remember what it was. It might be this. Maybe I just wrote it wrong. I don't know. Express h of x equals x plus 2 as f of g of x. This is really simple. Basically, what they want you to do is they want you to make it look like a function in a function. So in this case, what you would do is you just say like, well, is there an inside function? And yes, there is. Like x plus 2 is on the inside, right? So you take whatever's on the inside and you call that g. So you say g of x equals x plus 2. Okay? Then what you do is where I just pointed g at the x plus 2, well, replace the g there. And it would say, replace it with g, I should say. If I replace the x plus 2 with g, it would say g to the 6th, right? And this is basically your f. But you want it to be f of x, not f of g, so you write it as x to the 6th. And that's the whole thing. Basically, if you took the x plus 2 and you put it in for x, you would get this, right? That's all they're asking. So the inside function's g, and basically whatever you don't make g, in this case the 6th power, that's f. So it's actually surprisingly simple. So like on this one, it says, if f of x is x to the 6th, the function g is actually, they didn't even make us do both parts. So g is the inside. Yeah, so that's not hard. Okay, so I think that's going to be it for now. If you have any trouble, you can email me, get an extension on the homework or something like that. But that's it for now, and I will talk to you guys later.